Okay, 3.2, number 16. F of x is equal to the cube root of the absolute value of x. So we have a couple ways we could write this. We could think of this just the absolute value of x is x. If x is greater than or equal to 0, it's negative x. So we can think of it as the cube root of x, or the cube root of negative x. Or we could write it as a fractional exponent. We could shift it either way. And we could write it as f of x equals the absolute value of x to the 1/3. So I could change that and leave the absolute value up top, which might be a little bit more straightforward approach is to rewrite this as this, and then we know that the absolute value of x is either equal to x when x is greater than or equal to 0, or negative x when x is less than 0, and that would be negative x to the 1/3. We would have to put a parenthesis around that. This way we kind of work it out. Because we realize that if the cube root of -1 is -1, so that is all right either way. So hopefully that's all right. Okay. If it would have been the fourth root, that'd be different. You'd have to put a parenthesis around it, and then that -1 would disappear. But that would always be positive anyway, so we wouldn't have to worry about the absolute value. Okay, so this is what we got. So this is my piecewise function. This is the way I'm going to use it. To describe this, add x equals 0, so a is going to be 0. So remember, this is the derivative. This is the formula for the derivative. It's a limit at a point A. Sometimes we write it as x for a general point, but this is at a point A. Now the left-hand derivative, and we're going to use our piecewise function. This is going to, again, be the limit as h approaches 0 from the left. So I'm going to be just to the left of 0, so I'm going to be subtracting. So since a is 0, you'll see over here, let's first of all just, this is our general form. Then when we put 0 in, you could see that as h approaches 0 from the negative direction, this will be a negative number, so this will be to the left of 0. Okay, and this will be equal to 0, of course. This is right at 0. So since this is to the left of 0, I'm going to use this function here, so negative h to the 1/3. Since this is right at 0, I'll use this one, positive. And that doesn't matter in this case, because even if it's negative 0 and positive 0 are both to the 1/3 will both be 0. So that's going to drop out, so this is what I have. Then I can think of this, again, I can take this, leave the negative in the top, and I can put the 1/3 in the bottom as a negative 1/3. So h to the first, which is 3/3, times h to the negative 1/3 is h to the 2/3. And again, we want to evaluate this, so we'll use that very small approach. Works pretty good. And we're just going to be to the right, so it's going to be to the left of 0, so it's going to be a very small negative number, so negative 0.00021 to the 2/3. And I can separate this. I got a negative on top. Now this becomes a negative 1 to the 2/3 times of the very small number, 0.000 down to 1 to positive 2/3. And if I take a negative 2/3, if I take the cube root of negative 1 to 2/3, if I take the cube root of negative 1, I get negative 1. Negative 1 squared is positive 1, so that just becomes positive 1. This is negative 1. So positive 1 just absorbs, and then I can break this up into 1 to the 2/3 over infinity to 2/3, which is just, again, 1 over infinity. I can invert multiply, so I still have my negative sign, so that's negative infinity. All right, so that negative sign still survived all that. So I have a negative infinity. That's my left-hand derivative. Now my right-hand derivative, I wrote limit, should have written derivative, sorry about that. It should be the right-hand derivative. Let's fix that now. Although a derivative is a limit. A derivative is a limit, but some problems we're using left and right hand limits, and we're using left and right hand derivatives. So the right hand derivative, it's going to be the limit as h approaches 0 from the right of f of a plus h minus f of a over h, and then I'm going to be at 0. And again, now as I approach from the right, this is going to be greater than 0, so I'm going to go back to my piecewise function, so I'm going to use this function here, x to the 1/3, for both places. Because this will be greater than 0, so I'm going to use it here. I'm going to use it here also. So it'll be h to the 1/3 minus 0 to the 1/3 all over h. So I'm using that part. Now this just becomes 0, so I just have h to the 1/3 over h, so notice I have a positive sign here. So I got 1 over h to the 2/3, and that's 1 over a very small number to the 2/3, which is 1 over 1 over infinity to 2/3, and that's 1 to the 2/3 over infinity to 2/3, which is just 1 over infinity, such as positive infinity. So what have we got? Well, the left-hand derivative was negative infinity, if we go back over here. Remember, our left-hand derivative was negative infinity. And my right-hand derivative is positive infinity, so what have I got? F of x has a cusp at x equals 0. Okay, that makes sense.